Okay, so this is going to be a long lesson, so I think I'm going to break it up into parts just so that it doesn't feel like it's 20 minutes long in lesson. Okay, so this is Unit 5, Section 6, and we're talking about radical expressions. And there's a lot in this section, so like I said, I might break it up into different videos. Okay, the first thing is on the notes is, what does simplified mean? So if you're using the typed out notes, this is, I'm going to fill in the blanks here. If not, you can just copy it down. If we're talking about simplifying a radical expression, the first thing, the index is as small as possible. Okay, so the index is as small as possible. The next thing is the radicand contains no factors that are the nth power of the integer or the polynomial. And this part's already written out. Contains no factors that are the nth power In other words, if there's a jailbreak that can be done, you have to do it. So you have to pull out anything that can come out from underneath the radical. No fractions in the radicand. And no radicands in the denominator. So as you can see from this list, there's a lot of work to be done on these problems. And you have to make sure that once you've done the problem, that you then simplify it all the way, because you'll lose points if you don't simplify it. So we're going to start out with the product property of radicals. Okay? If they both have the same index, then they can be put under the same radical. Okay? So, for example, number 1, the square root of 3 times the square root of 5. These are both square roots. Remember, if there's no little number, no index, it's an understood 2 there. So the square root of 3 times the square root of 5 is the square root of 15. There's nothing that can be pulled out of that. There's no simplifying that, so that just stays the way it is. Okay, so that's the answer. Let's look at number 2. On the outside, we have a 5. On the inside, we have a 63. Okay, in this case, we have a plain number, 5, multiplied by a radical. So this is what you want to do. You first want to see if there's any jailbreak that can occur. So you might come off to the side if you're not sure and take 63 and prime factor it. It's 9 and 7. I almost got that wrong. 7 is prime, and then 9 is 3 and 3. Again, I always circle my prime so I don't lose them. Okay, so now once I've done that, I can see that there is a jailbreak that can occur here. The 3's can group together, come out. Remember, something horrible happens. They don't all make it. But what is happening is 5 is multiplied by whatever comes out. So in this case, a 3 comes out. 7 is left behind. 7 doesn't have a partner, and so it has to stay inside the radical. And so my final answer here would be 15 root 7. So that's what you do when you have something on the outside of the radical. Nope, that's not what I wanted. I want it to get... Okay. All right, number 3 is 3 root 12 times 2 root 21. Now here's my trick when I do this. Whenever you're multiplying products like this, it's always the outside times the outside and inside times inside. So really what we're doing is we're regrouping. So the outside is 3 times 2. That's what's on the outside. And then we have the radicals. But instead of writing 12, I'm going to prime factor 12. So let me show you this color coded. So 12, I'm going to write as 2 times 2 times 3. And then I'm also going to prime factor 21 when I multiply. Instead of multiplying, because we want to pull out, we don't want to multiply and then have to prime factor. It's easier to prime factor smaller numbers, so 7 times 3. Now we can easily see what needs to come out and get multiplied on the outside. So we have a 3 times 2 waiting on the outside. And let's see, we can take a pair of 2's out because this is a square root. So that pair of 2's comes out. And we also have a pair of 3's, and they can come out, and then left behind is our sad little 7. 7 doesn't have a partner, 7 gets left behind, he doesn't get to escape. So that's the square root of 7, and then you multiply the outside. 3 times 2 times 2 times 3, so that's 36 root 7 is your final answer, simplified all the way. Okay? All right, number 4 is 7 root 72. Again, this is very similar to number 2, so I'm just going to, well, no, I can't just do it in my head. So if we prime factor 72, it's 3 times 3 times 2 times 2 times 2. If we take out our pairs, we have a pair of 3's, and we have a pair of 2's, and so we have 7 waiting on the outside, a 3 escapes, a 2 escapes, and left behind in our prison are sad 2. And then 7 times 3 times 2 is 42 on the outside and 2 on the inside. And that's your final answer. Okay, so that's the product. Now the next property is the quotient property of radicals. So the quotient, whoops, did I spell that wrong? Yep, I just put an I in there for no good reason. The quotient property of radicals. Okay, and the way I wrote this is, if I have a fraction, a over b, like this, we can rewrite it like this. We can split it up. And we're going to have to do that in a minute, and I'm going to show you what that means. So let's look at 2 simple examples. Number 5. Not that they're not difficult, they're just a little bit simpler than what we'll do in a minute, is square root of 49 over square root of over 9. So we could split this up and do the square root of 49 over the square root of 9. Well, if you don't know, the square root of 49 is 7, and the square root of 9 is 3, so that just simplifies to 7/3. Number 6 is the square root of 2 25ths. Again, we can split this up in the square root of 2 over the square root of 25. Well, square root of 2 can't be simplified, so that stays square root of 2. And the square root of 25 is 5. This is going to be your final answer. There's nothing more you can do to simplify that. Okay, now, one more thing before I pause and start a second video. This is called rationalizing the denominator. You may have noticed on 5 and 6, none of the answers ended with a radical in the denominator, and we already talked about that as one of the things that you can't leave. It's not done if you have a radical in the denominator. So what happens if it doesn't simplify like the square root of 25? So let me show you an example of that. 7 square root of 15 over 2. Okay, this one's not going to come out as nice. So we have the square root of 15 over the square root of 2. But we cannot leave that square root of 2 in the denominator. That's an illegal move. We have to get that 2 out. Well, there's no partner for 2 to escape, so we have to orchestrate or cause a jailbreak. Well, what do we need in order for 2 to come out? We need another square root of 2. We need a partner for 2 to escape. But we can't just multiply the denominator by something. Remember, anytime we multiply by bring something into the problem, we have to multiply the numerator and the denominator by the same thing. And the reason is we're really just multiplying by 1. It's a special looking 1. It's a square root of 2 over square root of 2. So we're not changing the value of this expression, and that's important. We're maintaining the value, but we're manipulating it to work for us. So then what we have here then is a square root of 15, which is 3 times 5, and the 2. And on the bottom, we have the square root of 2 times 2. Now we do our jailbreaks. In the top, there's nothing, so we can put that together. Square root of 30 is always that thing that looks like something should escape, and it doesn't. And then the square root of 2 times 2, well, a 2 can come out. Now we're simplified. Now be careful. There's this part of you that wants to make this the square root of 15. You cannot. The square root of 30 is not actually 30. It's the square root of 30. And so we don't know what that is divided by 2, and I don't want a decimal. We'd have to get a decimal there. And so we have a 2 on the outside and a square root of 30 on the inside. That's visitors and prisoners. They can't interact. So I'm kind of saying that in a couple different ways. So that's done. Nothing can escape. 2 can't go into 30 because it's under the radical. It's not actually 30, okay? So let's look a couple more of these. If we have the square root of x to the 4th over x to the 5th, okay? So let's start with, we have the square root of x to the 4th over square root of x to the 5th. Now there's a couple things you can do here. You can start by simplifying and then rationalizing, or you can just rationalize and then simplify. I happen to be of the feeling of I rationalize then simplify. I look at this and I say, well, the square root of 5 needs to come out. So what do I need at the bottom? I need another the square root of x to the 5th needs to come out. So I need another square root of x to the 5th. Again, remember, if you don't multiply the numerator and the denominator by the same thing, you're breaking the rules and you're going to get it wrong. Because we're multiplying by 1, therefore not really changing the value. Okay? So then what do we have on the top? We really have 1, 2, 3, 4, 1, 2, 3, 4, 5. Now you don't have to write them out. I'm just showing you what we have. And on the bottom, I'm not going to write them out because really this is what we have. Okay? So what does that mean? Well, let's do some jailbreaking. We have 1 group, 2 groups, 3 groups, 4 groups that can escape. So if 4 groups can escape, that's really not 4x, that's x times x times x times x. Left behind is an x. On the bottom, what can escape? Well, x to the 5th. I didn't bother to write them out because I knew I already had partners. So I just made them escape this way. Now look what happens. We're not done. Really what this means is x to the 4th over x to the 5th, and then we have a square root of x. Well, x to the 4th over x to the 5th can be simplified. How many x's are going to be cancel out? Well, 4 of them are. Where are the x's going to end up? They're going to end up on the bottom because there's more of them. And how many? There's going to be 1. And what's left on the top is the square root of x. This is your final answer. Now, I did a lot of work on number 8. I did 1, 2, 3, 4, 5, 6 steps. It's really up to you. Some of these steps you may be able to combine and do it a little simpler. If you're photomathing it and just writing the answers down, you're not learning the material and you're cheating. Just put that out there. Okay? Number 9. Let's see what number 9 looks like. Let me make it bigger. Number 9 is the 5th root, which means if it's the 5th root, that means we need groups of 5. 5 over 4a. Now this one you got to be careful because look what happens. Okay? I have the 5th root of 5 and I have the 5th root of 4a. Well, I need that 4a to be able to escape. But I don't need pairs. How many do I need in order for them to come out? I need a group of 5 4a's. Well, we have 1 4a. So I need how many more? I need 4 more of them. 1, 2, 3, 4. And just like I told you before, whatever I do to the bottom, it doesn't matter what I do. You just have to do exactly the same thing. So the numerator and the denominator better match when you do this. If not, you're doing it wrong. So then let's see what we have on the top. On the top, nothing simplifies. And here's the reason why. We have a 5. Well, that doesn't have 5 partners to escape, so the 5 is still there. And then we have 4a, 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 4a. Well, that's only a group of 4. We need a group of 5. So really we have 5 times 4 times 4 times 4 times 4, which now that I'm thinking about it, I don't know off the top of my head and I didn't write the answer down. So 16 times 16 is 36. Carry the 3. 9, 6, 1, 6, 256. And then we got to times that by 5. Holy crap. So that's going to be 30, 25, 28, 1,280. I don't have a calculator handy. Oh, I'm an idiot. I have a phone sitting right next to me. Anyway, and then we have a to the 4th. None of them can come out because it's a 5th root. On the bottom, though, we have 1, 2, 3, 4, 5 4a's. So a 4a can come out. Now again, you're going to be tempted to cancel the a and the a to the 4th that's under the radical. You're going to be tempted to see if 4 goes into 1280. Don't do that. If it's under the radical, you can't simplify it from something that's just a simple number, because that's really not 1,280. It's the 5th root of 1,280, and we don't know what that is, and it's a decimal, and you can't give me a decimal answer. Okay? And we really don't know what the 5th root of a to the 4th is at this point. We can't do anything with that. Okay? All right. One more, and then I'm going to start it. Oh, no, that's the last one. And then, okay, so I'm going to stop here. This will be part 1, and then I'll start part 2 in just a minute.